Well, in this specific example, we have problem number 8.45T. In this specific example, we have a 38 men, so that is the sample size, and in the standard deviation of this sample is 9.8 beats per minute. So we need that information. N equals 38, and S equals 9.8 beats per minute. If you keep reading this problem, they say that we have to use a 10%, I'm sorry, a 10% significance level, that is 10%, 0.10, to test the claim that the pulse rates of men have a standard deviation equal to 10 beats per minute. So this is the claim. The claim, when it says equal, that means the claim will be on the null hypothesis. When the claim is on the null hypothesis, the alternative hypothesis is not equals. That indicates you have two tails. Okay. Well, the first step is, of course, you have to determine the null hypothesis and alternative hypothesis. Again, when the claim is on the null hypothesis, when the claim says that it's equal to certain value, that means the claim will be on the null hypothesis, and the alternative hypothesis will be not equals to. So this is the correct decision for the null and alternative hypothesis, and the claim is here. To compute the test statistic, we use the formula. We use this formula n minus 1 times s square over sigma square. That sigma corresponds to the sigma that is in the null hypothesis, this sigma right here. So if you actually do this computation, 37, I'm sorry, it's 37, right? This 38 minus 1 is 37. S is 9.8 to the second power. The sigma that is on the null hypothesis is 10 to the second power. So we get the calculator and we compute that. Let's do it. That'll be 37 times 9.8 to the second power divided by 10 to the second power. I have 35.5348. In this specific problem, they want you to round this up to round it off to 3 decimal places. So our answer, the answer you type here is 35.535. Next thing to do is find the p-value. Well, this again is a two-tail situation, to have a distribution of two tails, where the test statistic is 35.535. This is the correct settings. I'll tell you why this is incorrect. Writing this test statistic here will be incorrect. I'll explain you this in a moment. First of all, the p-value is this area plus this area. So to find this area, we need to find the function on the calculator that is chi-square CDF. So the p-value is equals to twice chi-square CDF. The lower limit is 0. Remember that this distribution, this type of distribution, starts at 0. So that will be 0. The upper limit is this number right here, 35.535, comma. Well, in this case, the degrees of freedom, you need degrees of freedom for this, of course. Remember that is n minus 1, which in this case is, we have 38. 30 minus 1 will be 37. So you gotta type this on the calculator. So for that, let's open the calculator. Let me show you how to type that one. That'll be second vars. We go all the way down to for me it's number 8. In my calculator it's number 8. You need to scroll down and find number 8 here. You can also press 8, and then the lower limit in my case is 0. My upper limit is 35.535. Degrees of freedom is 37. And all I gotta do is press enter here and paste. That'll give me this area right here, this area on the left. But remember, you need to find this area as well, which is the same area as this size, so we multiply by 2. That is my p-value. The p-value will be, in this case, we round up to 4 decimal places. That will be 0.9245. Let's write it here. 9245. Okay, that will be the p-value. Now let me explain you why placing the p-value here, the test statistic here, will not give you the correct p-value. If I place the test statistic here, incorrectly, of course, that is incorrect. Okay. What is going to happen here is when I apply my, when I try to find this p-value, second vars number 8, that is chi-square CDF, make sure it says right here CDF. The lower limit will be this value, 35.535. The upper value will be, you can write any big number you might want. 10,000 is, I usually use 10,000. You can use 100,000. You can use whatever crazy value, 1 million. Degrees of freedom is still 37, and you get this this area. But pay attention here. This area is this area right here on the right tail. You still got to multiply by 2 because you need to find this area as well. So when you multiply by 2, what you get is a p-value greater than 1. And so as you remember, guys, no probability can be greater than 1. So this is incorrect. Okay, that is not correct. Placing the test statistic here is not correct, and there is no way to know it until you do this step. If you get a p-value that is more than 1, that means you place the test statistic wrong. So that's correct, and this is not correct. Okay. The next part of the problem. Let's see the next part of the problem. Right here. Once you find the p-value, which is this number right here, you gotta state the conclusion. The conclusion is, do not reject the null hypothesis. Remember, guys, when the p-value is greater than alpha, which is the significance level, in this case, remember alpha was a, if I go back to alpha, alpha is 0.10, right, 10%. So alpha is 10, right? 0.10, I'm sorry, here. So of course 0.925 is 9245 is greater than 0.10. That's why we failed to reject. We say we failed to reject, or do not reject, which is the same. We failed to reject. And because the p-value is greater than, okay, that's the reason why you fail to reject the level of significance. So there is insufficient evidence to warrant rejection of the claim that the standard deviation of men's pulse rates is equal to 10 beats per minute. Now, guys, here in this situation right here, if you guys remember, the claim was here on the null hypothesis, and we failed to reject. So we need these two elements to know how to word the conclusion. Look, in this case, you see all these are all the possible combinations you might have. It says right here, the original claim is on the alternative hypothesis. That's not the case in this situation right here. The original claim is on the alternative hypothesis. No, it's not the situation. The claim is on the null hypothesis for our problem here. The original claim is on the null hypothesis. That's correct. Yeah, that is our situation. But it says, and you reject the null hypothesis. No, that's not our situation. Our situation is the original claim, the claim is on the null hypothesis, and you fail to reject. That's what we have in this particular situation. So that's why we order like that. There is no sufficient evidence to warrant rejection of the claim that, well, the claim is this in this case that the men's pulse rate is equal to 10 beats per minute. And that's how you do this specific problem. Let me mention something here. If you guys have a TI-83 calculator, the way you type it out is the same. Basically, I mean, you have a TI-83. Let me just show you real quick how to type it out. You press second bars. If you have that's number 7 for my in this particular situation. Make sure it says CDF, chi-square CDF. So in this case, the lower limit is 0, comma 35.5. 35 is the upper limit. 35.535, comma degrees of freedom is 37. You need to type 37 as well, and close the parentheses. And once you got this number, you multiply by 2 because it's a double tail. You only multiply by 2 when you have 2 tails. If it is not the situation of 2 tails, you do not multiply by 2. So that's how you get the same number using the T83. As you can see, it's pretty much the same. And that'll be it. Thank you.